Alright guys, so this one is just slightly more technical than the introduction. Hopefully this will give you an idea of what I'm doing with Numerai, the classic tournament. So my name is Jo-fai Chow, or you can just call me Joe, which is easier to remember. So I've been doing Numerai for 2.5 years, thanks to the pandemic, because I stayed at home and got nothing else interesting to do, so I found Numerai, and it was well worth it. I also organize these meetups for Numerai. So this is not my job, so I don't work for Numerai, but this is my hobby. So thanks Richard, thanks for funding, thanks to the Council of Elders for the support. So we've been doing this. This is the second time, so we did the first one in London, and this is the second one in New York for you, Richard. So this is my Numerai profile. So I got, I think I got 3 NFTs now, one from London, so I got 3 ones. But these are my models, so you can see that here. Places, look at it from my background, the background of the profile, so these are my models. So my background is in civil engineering, so I'm not a boring traditional engineer. I was, and then I tried to get into data science by doing cargo and other stuff. And somehow I worked for a company in the US, and I'm going to work for someone else later on. If you want to contact me, this is my Twitter and LinkedIn. So that's me, Jo-fai. So just a bit more about the meetup. So this is how it started. So back in April, I think it's early April. So we all went to Numerai, which was really cool. Weird, but really cool event. First conference I feel weird, but at the same time really excited about all the things to talk about. And then we talked about doing something similar, but in a smaller meetup elsewhere. So I spoke with John Taylor and others, and I came up with the first proposal about meetup. So I call it Around the World with Numerai, so Numerai participants. So this got accepted. Thank you for the support. So we did the first one in London back in July, just 2 months ago. So you see Alex there, me, and John, and then we got full people. So that was really successful, so we decided to do it again. So this time today in New York City. So I went into the swimming pool for the photo. I really like it. Such a good picture. Okay, so we already heard about the Numerai tournament, so I'm not going to repeat that. So I'm going to head straight into V4 data, which is the data version of the data from Numerai. And I want to tell you how I slice it for my 1 year. Okay, so I got links from the presentation. You can, I will share with you after this event. But I'm using this version of data right now. So we have both training and validation package, or in other font. I actually put them up together to create my own data set, which I will talk about it later. But all you need to do right now is to just get the live data set and make the predictions and submit that right now, which should be, in theory, to be really quick. There was like a few changes after we have the V4 data. So we have a forum post about some dangerous features. They're not like hurting you, it's just like they have changed in their nature from the time that they were created and from today's the different mechanism of creating these features. So these are features that we want to, so I want to exclude them from any kind of experiments from now on. So that's what I'm going to do in this example here. So first, let me just show you one baseline model. This is based on the example script. So you already heard about the sample script from the first talk. So I'm just using the same kind of parameters, but I'm using a different feature sets. I'm using the V4 data for the medium feature sets. So the original medium features, we got 472 features, but because we have some dangerous features, I have to remove them from that. So there are like 4 of them inside that included in the medium features. So I take them away, so that becomes 468 features. So I'm using that, put it into the simple example script. Run the same kind of model on LightGBM, like 3 different seed package, and I use that as a baseline model. And just before I go to the actual performance of the baseline model, I want to show you how I actually validate my model. So as I said, I use both the training and validation data together. So create the whole thing together up to from era 1 to 1000. So 1000 is easy for me to figure out how to slice. So you get to about 100 and 1020 something right now. I forgot the actual numbers. And it's expanding every week because we've got a new data set coming into the validation set every week. But I'm only using the first 1000 years. And the way that I do it is that split them into 5 groups, and I have some gaps in the middle, say it's called the embargo, or just the gap between different groups to avoid the data leakage. Or do ask me anything when you have some questions. Okay, so this is like how I do my validation. And then when I actually do the training or any tuning, I'll use the first group here for training the model. The second group usually is for tuning. So sometimes you want to look at how you define the early stopping. So I use the second group here to tune the model. And finally, I use the third group here to actually do the validation. So I'm capturing the information from just 3 groups here, just 3 group of validation sets here. Okay. But if I go back to the sample set, they already have the number of trees, the number of estimators, so I don't need to tune anything. I just use this model to train it. I ignore the tuning set. I just validate only this first group. If that makes sense to you. Okay, so that's how I did it. So this is like the looking at the correlation with the target Jerome 60. So I'm not looking at the Lomi 20 or Lomi 60. I'm not doing this because there was a change to the leaderboard. So we saw a new change looking at Jerome 60 as a new target. So that's why I'm trying to use that as my base of evaluations. So looking at that, the base model or the example script is actually quite strong. Really good. Got a Sharpe ratio more than 1. We got 84% right. So when you got a positive correlation, that means you're getting a positive return from the payout for now. So this is like the baseline I want to beat. So by beating it, I mean that I can try to optimize my model to get maybe a higher mean correlation, maybe higher Sharpe ratio, higher Sortino ratio, or lower max drawdown. So these are the target that I want to optimize. And obviously, I want to have more percentage in terms of getting it right over time. So these are the things that I can use to judge whether I can beat the baseline model. Okay, so how do I do it with my simple approach? So first of all, look at some of the features that I can use or ignore for the model. So one thing I did was evaluating different features individually. So for example, this is like it's kind of similar graph, but I'm only using one of the features and compare it against the target. So I can get correlations, year-wise correlations from between these features and the actual target I want to measure. And I can also get some kind of value, right? So I can get the mean, correlations, the Sharpe ratio, and all that. So I can do this for all 1,100 features, and I will have different graphs. So from these numbers, I can tell which feature are more stable over time. So maybe they have a higher Sharpe ratio, maybe they have a higher Sortino ratio. So these are some information I can use to look at different features, whether I can use them for the model or not. So this is what I do. So I did it for the medium set and the full set. So this is only showing the medium. So I evaluate different features individually. I get the numbers, I get the correlation, the standard deviation, the Sharpe, Sortino, everything. And I can put a rank to them. So I can rank them by the actual individual scores. So that now I have a ranking for each feature. I can use this ranking to do the next step, which is slicing my data. Does it make sense so much?
And are you doing this in a cross-validated way? Or this is just the overall data?
Because this feature, that is the same over time. So just do it in one go for all the 1,000 euros, and just look at the year-wise average for all this. But the main thing here is just to make a comparisons between different features. So which one is more riskier than the other? That's what I want to get to. So this actual number may not mean anything at all, but when they put together comparatively, they will give me some information to slide with it.
Look at an autocorrelated way.
I haven't. So that is something that I didn't do in this step. But the one that I did for the optimization in a few steps later, that kind of do it for me because I optimized both the selection of data and the parameters for the machine learning algorithm together. And the hope is that I will find some of the combination that works with higher Sharpe, higher Sortino, and so on.
I mean, autocorrelated
features, right?
Features are
yeah, I didn't do that step here.
Yeah,
so this is like a pure simple slicer. It's a pure simple way to just slide different figures. The other way to look at it is that this is like using the medium set feature. So some of them, they are not that correlated when you compare it to like the whole full set with 1,100. So that's something that you can also do with this. You can also get another column here saying how is this correlated to the other features. If there's too correlated, you can just eliminate.
Auto-correlated meaning you will correlate with your last error. So to see if this correlation are stable over time.
Oh yeah, I didn't do it. I didn't do it this time. But this is just a simple one. A simple look at how different features for the correlations and standard deviation. Really. So of course this is just one of the ways that I did in a simple way, but you can always make some improvement to that, right? So in a simple way, I just have a function here. So I want to look at for one of the set of features, I want the top X, maybe top 100 in correlation score or ranking, top set in Sharpe, and then top Y in Sortino. So at some point we've got a feature set here, which is filtered by different kind of settings here. So what I want to do is to optimize this number, optimize the way how I slice data to give me the perfect feature set here, to give me something that I can use to build a better model. Okay, so this is the next step that got everything, put everything together. So this step includes feature selection, which I just showed by using filtering. And then I'll also do the parameters tuning in one go. Because it's useful to do both together. Because when you have a different size of different set features, the parameters that you use for the last best model will not be, may not be applicable to that feature set. So I'll do this in one go. So a function that on a high level is just like this. So I can have a function that optimize the number of the top ranking in Corr, in Sharpe, in Sortino, and other stuff. And at the same time, it's the same function I can tune. This is for LightGBM. You see the LightGBM corners. I can do all together. And the good thing about this approach is that the outcome, the return of the score is very flexible. I can just look at maybe the mean correlations. I can look at chart ratio. I can look at feature initialized correlations and other stuff. So I can do whatever I want here, and I can use any optimizer like I use Bayesian optimization here, or you can use any like genetic algorithm or any other standard optimizer to do the same thing. So the most important thing is just to get the feature slicing right, the feature set here, and the parameters for that algorithm. This could be for some other algorithm, could be for neural network, could be for random forest. So this is the main thing for the function. So optimize the feature selection and tuning at the same time. So this is what I got. So maybe it's easier to compare them side by side. So on the left hand side, you see this is the baseline model that I tried to fit. And this is the one of the results that I got from the optimizations. So it got a slightly lower correlations, average correlations, but it's better in every other way. So it's higher in Sharpe, higher in Sortino, less drawdown and less mass drawdown. And then I also got a higher percentage for all positive correlations over time. So yeah, so this is how I did it.
How many features end up getting dropped?
So I think this model got it's using about 240, 50 features. So it's dropping about 200 features. out of the 460 something. Yeah.
Your computer must like it afterwards.
Yeah. The good thing about it is that it tries to reduce the size for the model or for the computer requirements. Because this is okay at medium, but if you look at the full set, you can use the same kind of steps to reduce the size of the features and make it easier to know. That's powerful. Yeah. So this model here is based on V3. So the V3 features I did the similar thing, but the V4 features that I'm doing right now, I haven't got a model yet because as you know, you move from Numerai 20 to Numerai 60, and then I've got the dual 60. So I did it again and again and again 3 times. So I haven't put on the model yet. But I think so far, using the similar tactics, I think it is doing okay with FNC V3, some of the models. But I'm still trying to figure out a way to look at the TC.
Are these all your models?
No, if you look at the background, that's my model, right? So these are.
They're all very good.
Yeah, that's true.
They're okay, they're not really good with TC, but that's what I'm trying to figure out.
They're all positive.
Next, yeah.
Yes, maybe you're sorted by FNC.
So I'm sorted by FNC Wiki for now. So these are some of the models. But these are based on the V3 data. This is not based on V4 data because I'm still working on the V4 models. Okay, so
Do you do visualizing or want to customize loss function?
yes, so in this function here, so to go back. So I didn't show it here, but actually the return could be including the top and bottom 5 functions, and then feature initialized. So that could be the last score, because it can return multiple score, right? But I'm only looking at one score to optimize. So if I remember correctly, for the V3 set, I'm optimizing on the feature neutral correlations back in the days, and that makes sense because it's now doing it quite well on FNC, but not so well on TC yet. So we'll see. Okay, so some conclusions here. So I'm just showing you some simple way to do it, like how to use that different features. So that could be more improvement that you can do it yourself. I'm trying to optimize both feature selection and the tuning of the elbow together because I think that's the right thing to do. And then the ultimate goal is to provide some stable predictions over time. So high Sharpe, high Sortino, low mark Drawdown, and that's the hope. I cannot say high TC here because you cannot actually optimize TC. So all you can do is just to upload the model, observe for a bit, and then hope for the best. So that's all for me. Any questions?
Do you worry about overfitting it? Because you're kind of like selecting features like almost manually in a way.
Yeah, I think
It's almost like cherry picking.
so. I guess the only real feedback is when you stick on the model and you get hurt and then you know you're overfitting, right? So, but the good thing is that we have 50 slot. So I try my best to do my local validation right. Try my best to do it correctly without leakage. So without if I go back to this one, without any past information or future information feeding back to the old model. This is the best I could do right now, and the rest is like you upload the model, observe for a few weeks, and see how it goes. And then when you get burned, you know it's overfitting, right? So it's so easy to figure out. But that's the good thing. That's the best thing about Numerai. You actually get burned when you overfit, and that makes you change. That makes you rethink your strategy, rethink everything about the models, and try to be more careful with the when it's too good to be true, you have to be more careful of the models. So that's the great thing about Numerai, I would say.
I was thinking about, a lot of the feature importance stuff people do is just like, put the model into a random forest and put all the features into a random forest and see which have the highest importance. And this approach seems much better because you're really kind of respecting the time. Because if you take the Sharpe, you're kind of thinking about the time series in some way. So it seems like a very good idea.
So I did that before. So in the past, so the first thing we try put a random forest or GBM and get the feature importance, right? And then just use that to like I want a top 50, top 100. Back in the days when we only have 300 features, that seems to work okay for a bit, but I got burned.
Yeah,
I got burned.
That to me would make you overfit to like high core, low stability, or
Yeah, because before there was only about core. It's always about core, right? And right now we have to think about a more neutralized approach, a more stable approach. So this is the way. This is the way I did it. If it's not the best way, I would know when I burn or when I get burned. So yeah. Any other questions?
So you do post processing also?
I do have the cross validation sections and for staking for ensemble next stage. But I haven't done it for the V4 models yet because I haven't found the best combination of features yet. Because I'm still playing with the medium. I haven't played with the full set. So what I want to do is to put on some baseline models with V4 using the medium features, and then we'll spend more time on the full set because I think there's some value in the full set.
So post processing is like, do you neutralize your prediction?
I do when I try to evaluate the FNC, but because I tried that neutralization in the past, so to have one model version 8, which is no visualizations, and then version with different variation of visualizations, and I think that is not, from my experience, it's not that worth it. No, I know it's difficult to say because there was a period I remember in 2020 that all the neutralized models were doing a lot better than the visualization one. But after that period, I haven't seen any benefits of doing visualization after that. Maybe I just haven't seen this long enough. Maybe this is a long game. You have to look at 20 years. See, so I always have some thought for neutralized model. Just to observe the performance.
Nice.
What are your computer specs?
Oh, for this model?
Yeah.
So I actually spent a little bit money to get 120 gig memory on my main machines. That's really helpful. But that's only helpful to a point for the medium features. So if I want to go for the full features, I need to do a bit more, like, we want smarter than just putting everything in memory. Maybe I have to use Spark or other stuff. I don't know yet. I'm still playing with the medium set on V4.
Right now they have the int_a data format, right? So int_a is much more memory.
Yeah, I'm using that already.
But you're using it already?
But it's still because of, I think when we get to V4, the number of rows increase exponentially when you compare it to V3. So you can still do like simple ways. So when I started, it's always a lot smaller, so I can actually put everything into memory. But when you need to train the final full model, you still have to get everything into memory, right? So that will be the last bit. But for now, I'm happy with what I got. For now, is that just to slice it, try different things, and look at the cross-validation like this.
Cool. So how many weeks for the training?
How many weeks? So you can see this is 1 error is 1 week. This is 200. This is 200 weeks. And then there's a gap of 12 weeks, like 3 months in between. And that's how I do it. You can bigger or smaller gap, it's up to you. But for me, I think 12 weeks is enough for me, optimal for me right now. But this is what I've been using up to 1,000. There are actually more. I think there's more than 1,000.
Validation.
Yeah, in validation. So you can use more if you want. But that's what I got right now.
So you have 20 years worth of data.
Excuse me?
You have 20 years worth of data. 20 years.
Yeah, yes.
One hour.
Yeah. It's a lot of data, yes.
I guess you should, yeah. Jerome is about 12 weeks long, right? Jerome 16, so maybe that is the exact right gap.
Okay. That's good. That's good to read.
13 weeks, good confirmation from the CEO.
Oh, so with that,
Yeah, good guess.
Yeah. All good? Yeah. Thank you.
All right.